Okay, let us see this problem in Unit 5. This is also a very important topic, change of order of integration. You have two problems, so both the problems are important. This first problem will come in the IET exam for 10 marks. Okay, so let us start. So we know that our first integration may be x, okay, and your second integration represents your y values. Okay, and also you have one more clue that if you see any x's here, as you can see here, x, in this integration you have x square and 2 minus x. That means this integration falls on y. Okay, that means you are changing all your y into x terms. Suppose you have y square 2 minus x integral 0 to 1. Sorry, 2 minus y integral 0 to 1. Suppose if you have like this, then you should definitely say that this integration lies on x. Okay, so alternatively only you have to take. If you have x, it is representing your y. If you have y, it represents your x. So remember that. Okay, so let us continue. So what is your x integrals? So x equal to 0 to x equal to 1, and your y is y equal to x square to y equal to 2 minus x. So this is your integration. Okay, so yesterday we have seen one problem, right? The roughly sketch the diagram. Like that we are going to draw a diagram and then we will split the integration. Okay, so now I am going to draw an x-axis. This is your y-axis and this is your x-axis. Okay, okay. So first, what is x? X is 0. So this is a 0 and this is x and this is y. This is y dash, x dash, everything. So x equal to 0. So if it is x equal to 0, what happens? This is your x equal to 0. So it is going to fall on this line, right? So we can write this is your x equal to 0. So x equal to 0 is over. Now, what is x equal to 1? So let us see. Where will x equal to 1 fall? Approximately your x equal to 1 will fall here. Okay, so your x equal to 1 will fall like here. Okay, so this is your x equal to 1 line. So x equal to 1 is also over. Now going to the next, y equal to x square. Okay, so y equal to x square. What is y equal to x square? Y equal to x square, x equal to y square equal to 4ax, x square equal to 4ay. So all these equations represents what? The parabola. Okay, so whenever you see integration or equation like this, it represents it is a parabola. Okay, so always remember that if you see this, you have to draw a parabola curve. The curve should touches the 0 point to this and also like this. Okay, okay. So your parabola lies like this. Okay. Now your y equal to x is this line. This is your y equal to x square. So this is also over. Now finally we are going to draw 2 minus x. 2 minus x. Okay. So what is 2 minus x? Let us see. So we know this is x1. So your y1 will fall on this line like this. So this will be your y equal to 1 and your y2 will approximately fall on this line. So this is your y equal to 2. Okay, as you can see here, you have y equal to 2 minus x, which means the x is going to reduce. So this is your y. So this is your y equal to 0, this is y equal to 1, and this is going to be your y equal to 2. So from y equal to 2 to minus x. Minus x means you are reducing. So this line is going to fall on this. Okay. So this line represents your y equal to 2 minus x. Okay. So this is how we have to draw a diagram using the integration. So this one is also now over. Okay, and one more important thing is in your book, in example 5.3.9. Okay, 5.3.9 is this problem is 5.3.9. In the book, there is one figure, that figure is not correct. Okay, use this figure instead. Okay, that first figure is not correct. That first figure is not correct. Don't forget that. Okay, so use this. So this is y equal to x square. This curve, full curve is y equal to x square. Okay. Next, now I am going to draw a vertical strip here and also here. Okay. So this is the area of region that we got after all applying the integration. This is the region of integration we got the areas. Okay. So for throughout this problem, we are going to work on this region only. Okay, from here to this one. Okay, so I'm going to mark this as the integration 1, and this place is your integration number 2. Okay, let us see now. So now we are going to split the region. First region, integration equal to I1 plus I2. Okay, so what is I1? This is your I1. I'm going to draw separately, but it is not necessary in the exam. So first one, I1. I1 equal to, which one is I1? This one, this curve, and this one. So this is your I1. Okay, this region. This is y equal to x square. Here it is in the y1, and it is here in the down part x equal to 1, and here your yes, y equal to 0, and here your x equal to 0. Okay, so this is the region we have. Now we are going to mark the first integration equal to integral from where? 0. You are going to first choose the x1. So first choose the x and then y. So x is 0 to where? 1. And the next one, y. Where is y the curve falls? Y equal to x square to y1. It starts from x square to your y1. So this is your first integration. Okay. So this is your first integration. Now it is over. The remaining terms you have to write xy dy dx. Okay. So this is your I1. Now I am going to find I2 using this part. What is that part? I am going to draw separately. Okay. So this point is your x equal to 0 point, as well as your y equal to 1 point. So here also your x equal to 1 and y equal to 1, and this line is your y equal to 2 minus x, and this point is your y equal to 2. Okay, and this is what the vertical strip we have. Okay, so let us write now. What we have? X equal to 0. So for this y equal to 1, but x equal to 0. For x region, integral x falls from 0 to 1. Okay, the next thing, where is your y starts? Your y is starting from here and to this. So here, your y is from this one you have to see. So your y is starting from y1. This line is your y1 line, right? So y1 to y equal to 2 minus x. Okay. So xy dy dx. So that's all. So this is how you have to split the integration using the given curves. Okay. So this step is over. So this is your step 1. Step 1 is over. Now moving on to the second step. What is the second step? We are going to change. Now now we are going to change the order of integration. Okay, I'm going to change the order of integration. First thing, I'm going to choose the I1. Only the first integration I'm going to choose, and I'm going to change the order. What is the I1? What is the values of I1? Let us write the I1 first. Integral 0 to 1, integral 0 to x to, it is x2 to 1 xy dy dx. So this is the first integration we have. Okay, so what is the values? So as you can see, this is going to be your y because there is x. So this is your x, this is your y. So we can say that your x is lies between 0 to x equal to 1, and y is going to be lies between y equal to x square to y equal to 1. Okay, so what are the path we have? This is in the vertical order. Okay, both the path is in the vertical order v. Okay, so this is your vertical line. This is your horizontal line. Okay, next. So your x equal to 0 to x equal to 1. X equal to 0 to x equal to 1 is in the vertical line, and your y equal to 1 to y equal to x square is in also in the vertical line. So we are going to change both things. Okay, so both are in the verticals. I'm going to change it as an horizontal line. Now changing the order of integration represents vertical path into horizontal path, that is your x. Your x is your vertical path, and vertical strip into horizontal strip. So which is your y? Okay. Okay. So how it will happen after the changes? What will happen? So this is the correct order. Now I am going to draw a new figure after the changes. A new figure. Okay. Same. We have, what are the values we have? We can mark all the things. So x equal to 0. So this line represents your x equal to 0, and x equal to 1. So where is the x equal to 1 line? So this is your x equal to 1 line, right? So your x equal to 0 is not going to change. It is going to be same. However, it is change. vertically, horizontally it is revised or not, we don't care. So it is not going to change. But okay, so this x1 lines is going to fall on this side, and this x equal to 0 vertical x equal to 0 line is going to fall on here. Okay, so what happens means this is your x equal to 1 as well as your y equal to 1. Okay, so this is your y equal to 0 as well as x equal to 0. Okay, so the vertical thing we have changed into horizontal one. Okay, that's all the remaining things are going to be same. So what is y equal to y value? The parabola. I'm going to draw the parabola again. Okay, and also here this is your y equal to 1 so this is going to be your y equal to 2. So y equal to from y equal to 2 to x minus x. That means this line is going to be here. So this line is going to fall on here. So this is y equal to 2 minus x, that line. Okay. So what we have in the previous figure, we have vertical strips. Now I'm going to change it as horizontal strips. This is horizontal strip, and here also it is going to change it as horizontal strip. The region what we want. Okay, so same. This is your 0. This is y equal to 1, y equal to 2, and all other things. Okay, so first one is this one. So this is same I1. This is your I2. So let us see first now. So in previous I1, what we have? 0 to 1, 0 to 1, x square to 1, xy, dy, dx. This is your previous integration. Now, after changing the strips and line, we are going to find a new integration values. What are them? So first, where is the x? X is going to be here. Where is the x here? So your x is from 0 to 1. Your x is same. Here we don't have a line that, because vertically we have changed the vertical line into horizontal, but still we have our x's here. So where is this curve meets? The curve meets like x equal to 1. So we can write your x is from here to here, which means your x starts from 0 and ends at 1. So our new integration is 0 to 1. So the next one. What is the next one? You are going to see our y. We already know that this is your y equal to what? This parabola is your y equal to x square. So what we did, we have changed this strip into horizontally. So this is going to change. What happens? Your x equal to y square. Okay. So this is going to change your x equal to y square. That one we can write it as x equal to root y. Okay. So what happens? Your y is from where? 0 to root y. Okay. So this line. So this is your root y. Okay. So this curve is your root y. So this curve meets at from 0 to root y. Okay, so the remaining terms are xy, dy, dx. That's all. Now we are going to integrate. So first I am going to take this, writing in order, I1 0 to 1 integral 0 to root y. Here we have y. So this integration represents our x. So we are going to differentiate with respect to x. xy dx dy. Okay, first I am going to integrate this one with respect to x. So what is going to happen? Integral 0 to 1 y into, so integrating with respect to x. So we can keep our x, y into x square by 2. What is the values? For what we have to substitute? For x, because we are differentiating with respect to x. So x equal to 0 to x equal to root y into dy, which is equal to integral 0 to 1 y, your x square is root y square by 2 minus y into 0 by 2. This is going to be 0, and also we have dy. At the end we have dy equal to integral 0 to 1 y square by 2 minus 0 into dy equal to, we can take the 1 by 2 outside. So integral 0 to 1 y square dy. Now we can integrate this with respect to our y. So equal to 1 by 2. What will happen? Y square, if we integrate, it will be y cube by 3. So y is equal to 1. So y equal to 0. So 1 by 2, 1 by 3, 0. So this is 1 by 6. So this is the first integration. So I1 equal to 1 by 6. Now similarly we can see the I2. What is I2? Now this one is over. Our I1 is over. Now we are going to find our I2. So shall we draw this separately? Finding I2. What we have here? This one. Okay, so this is horizontal strip. So this line is y equal to 2 minus x, and this point is your your x is from, it is here, right? So which means this is your x is from 0 to so x is from 0 to 1, y is from 1 to 2 minus x. Okay. So what is the second integration we have found here? This one. So this one is integral 0 to 1 integral 1 to 2 minus x. So this is what we found. Now we are going to change it. So our x region is 0 to x is equal to 1, and your y region is from y equal to 1 to y equal to 2 minus x. Okay. So now this is your vertical path. So this is your vertical strip. Okay, now we are going to change both this into horizontal. Okay. So what happens we can see now. So I2, if we change, I'm going to change this. What happens? Here what we have 0 to 1. Okay, if we changed this and we now it is going to change it as our x is going to fall from 1, x is going to fall from x is going to fall from 0 to, so this is your, as usual, x's are going to be 0 anyway. So x is 0 to your x is, this is your one more x. So x is y equal to 2 minus x. And this one, where is, what is y? Your y is going to fall from 1 to 2. Okay. So your x is going to fall. So this is your x, right? So this is your y. X is going to fall from 0 to 2 minus x, which means this 2 minus x, y equal to 2 minus x. And this one y. So y equal to here 1 to, here y equal to 1, here y equal to 2. Okay. So what we have here, y equal to 2 minus x. What if we interchange it horizontally? This is going to be changed as our x. So x equal to, what happened? 2 minus y changed. Okay. Similarly, like what we changed previously, our x square equal to y, x equal to root y, we have changed, right? Similarly, we have changed this also. Okay. So this is how we are going to change the vertical path into horizontal path. So I2 is integral 0 to, sorry, integral 1 to 2. This is your y, and integral 0 to 2 minus y. This is your x. Okay. So this is your I2. Now let us see the integration. I2 equal to integral 1 to 2, integral 0 to 2 minus y, xy dy dx equal to integral 1 to 2. So first what I'm going to take? I'm going to take this. So this is in the x. So which means we have to differentiate with respect to x, which is in y. So we have to differentiate with respect to x. So what happened? X square by 2 into y into dy. Here we are going to substitute our x equal to 2 minus y and x equal to 0. Integral 1 to 2, 2 minus y the whole square by 2 into y minus 0 into dy. Integral 1 to 2, 4 plus y square minus 4y into y by 2 into dy. This is just a normal integration. So you know this very well. 1 to 2, 4 plus y square minus 4y into y into dy. So next 1 by 2 integral 1 to 2, 4y plus 4y cube minus 4y square into dy equal to 1 by 2 y square by 2 plus y power 4 by 2, sorry 4, minus 4 into y cube by 3, 1 to 2. Integrated again, okay? Integrated again. 1 by 2. So this can be cancelled. So what we have 2, your y is 2 square plus 2 power 4 by 4 minus 4 into 8 by 3. So this is your upper limit. Now your lower limit 2 plus 4 2 into 1 square plus 1 by 4 power 4 minus 4 1 cube by 3 equal to 1 by 2 8 plus 16 by 4 minus 4 into 8 by 3 minus 2 plus 1 by 4 minus 4 by 3. These steps you can solve. It is very easy step, common step. So now I am going to write the final integration I1 plus I2. So what is your I1? 1 by 6 and I2 is 5 by 24. So your I is 3 by 8. So that's all.